Now we solve NCERT textbook problem. Electric charge and fields 1.18 problem number. Here a point charge 10 microcoulomb is placed at a 5 centimeter directly above the center of a square of side 10 centimeter as shown. What is the magnitude of electric flux through the square? They are asking. Now see here, this is the square we assume. Whose side is 10 centimeter we take. Each side 10 centimeter we assume. Now what we are doing means we are placing a one charge directly above the center of the square, vertically above the center of the square. We are placing 10 microcoulomb of charge. We are placing 10 microcoulomb of charge. We are placing. So this is 5 centimeter we assume. Now see here, this line is perpendicular to this plane. Now what is the question in the sense, due to this charge, what is the flux through this cube they are asking? What is the flux through this square they are asking? What is the flux through this square they are asking? So to solve this flux through this square, what we have to do in the sense here, let us assume that here one square face is there. No, now 5 more square faces let us place so that we can get a cube. We can get a cube now. See here like this we will place this one side like that assume, and this another square face we assume like this. We place this one more square face, this one more square face like this assume. So totally now see here, this front face one, back face one, left side, right side, top, bottom, totally 6 faces are there. To these 6 faces, this charge placed exactly center of the cube is there. This charge is placed actually exactly center of the cube is there. We can assume that this charge also exactly center of the cube like that is there. We can assume, in which means at this point this charge is there. At this point this charge is there. 10 microcoulomb of charge at this point is there like that we assume. Now see here, the charge is center of the cube is there. According to Gauss law, electric flux through the closed surface, is equal to Q by epsilon naught, 1 by epsilon naught times of total charge enclosed by the closed surface. Now see here, this is the cube. Within this cube, this charge Q is known as 10 microcoulomb is there. Q is known as 10 microcoulomb is there. Now through this 6 phase, this flux through this charges, flux through this cube due to this 10 microcoulomb is Q by epsilon naught. That is according to Gauss law, flux through the closed surface equal to Q by epsilon naught. Now this Q charge is placed at the center of the cube, so that flux through the cube is equal to Q by epsilon naught. Now see here, this charge is placed exactly at center. That means symmetry to all the faces, so that the flux through each face should be equal. That means this flux is known as flux through 6 faces. That means this flux through the cube we assume, then flux through the cube is known as flux through 6 faces. 6 faces is known as, each face is known as one side, one square. That is equal to Q by epsilon naught. Actually, what is our question in the sense, what is the flux through one face? What is the flux through one face they are asking? So flux through one face is equal to, flux through one square is equal to 1 by 6 times of Q by epsilon naught. This much is coming. Here Q we have to substitute 10, and this 6 is there. This epsilon naught value, you know value. Okay, now see here, this 10 and 6 if we cancel, we are getting 5 by 3 epsilon naught we are getting. Since microcoulomb is given, so that we are taking 10 power minus 6 we are taking. 10 power minus 6 we are taking. And you know that flux formula is generally EA cos theta, electric field intensity into A into cos theta. Electric field is Newton per coulomb. Electric field is Newton per coulomb. Area is meter square. So that Newton meter square per coulomb. Newton meter square per coulomb is the unit we can take. Cos theta no unit. So this is the flux through, either we can tell as a one side or one face of the cube, like that we can assume. So answer for this question is 5 by 3 epsilon naught into 10 power minus 6 Newton meter square per coulomb.